What's up, CalcuBots? Here I have another video on something called the factor theorem. So the factor theorem states the following. A polynomial p of x has a factor x minus k if and only if p of k is equal to 0. This is actually an extension of the remainder theorem because the remainder theorem states that if you have a polynomial and divide it by x minus k, then the remainder is that the polynomial value at that at the k value of x minus k. So it's a special case of the remainder theorem because the remainder theorem, the remainder is not always going to be 0. It can be anything, right? But the factor theorem takes it a step further. It says that if you divide p of x by x minus k and that p of k value is equal to 0, that is, the remainder is 0, then that means that x minus k is a factor of it. Okay, so it's a special case of the remainder theorem where the remainder is equal to 0. We call it the factor theorem because this guarantees us that if at that value p of x is 0, then x minus k is a factor. So we're going to apply this to a few problems. All right, and the first one I have for you guys is the following. I'm going to move it up now so we can do some examples. So feel free to take notes on what the factor theorem is. But here's the first example I have for you guys. So number one, I have 2x cubed minus 9x squared plus 13x minus 6. And they give me the following factor, right? X minus 1. Let's check if this is a factor. All right, so my polynomial here is p of x. You can call it f of x if you want, but I'm gonna call this polynomial p of x. So let's check if p of k is equal to 0. So in this case, k is equal to 1, right? Because this is in the form of x minus k. So our k value in this case is in fact equal to 1. So let's test it for p of 1, right? So p of 1 is equal to 2 times 1 cubed minus 9 times 1 squared plus 13 times 1 minus 6. All right? I'm applying the factor theorem because if p of 1 is 0, then that means that x minus 1 is a factor of my polynomial p of x. So let's keep going. All the 1's raised to the exponents are just 1. So this is 2 times 1, which is 2, minus 9 times 1, which is 9, plus 13 minus 6. Let's do it piece by piece. 2 minus 9 is negative 7, plus 13 minus 6. Negative 7 plus 13 is equal to 6. Apologies. And we have that 6 minus 6 is in fact equal to 6. So we can confirm that because p of 1 is equal to 0, then this right here is a factor of my given polynomial. So what we can do now is divide it to find out what it is when you divide it. All right, we're going to get a quadratic. So let's do some synthetic division. 1. And I'm going to grab my coefficients. It doesn't look like I'm missing any term. I have 3, 2, 1, 0. So we don't have to plug in any zeros. So my coefficients are 2, negative 9, 13, and negative 6. So let's do some synthetic division. We drop the 2. 1 times 2 is 2. We add them. We get negative 7. 1 times negative 7 is negative 7. We add them. We get 6. 1 times 6 is 6. We add them. And we get 0. Cool, cool, cool. So our remainder is 0, which means that this value right here, x equals 1, is in fact a root. Right? This is a root. Or a 0. Remember that they're called the same thing, roots and zeros. So let's rewrite our polynomial now. All right, our polynomial becomes p of x is equal to what our factor was given to us as x minus 1. We confirmed it is a factor. And then whatever I have left over. In this case, I have 2x squared minus 7x plus 6. All right. This is our new p of x, right? It's still the same thing as the original one, because if you multiply this out, you're going to get what we started with. So now we have to find the remaining zeros, okay? Use the factor theorem. Given the factor, use the factor theorem, find all zeros for the given polynomial function. So now we can find the remaining zeros here. It looks like I can break it up by factoring. So we're going to have x minus 1. And I'm going to factor this out, okay? I'm going to do it over here. So right here, this one in yellow, I'm going to factor it out, all right? And I'm going to use the ACB technique. So this is how you do it. All right, here we go. We're going to factor that out. So I have this. From the boxed-in polynomial, I know that a is equal to 2, b is equal to negative 7, and c is equal to 6. Cool, cool, cool. We can multiply 2 times negative 6, which is AC. So AC is equal to 2 times, not negative 6, I'm sorry, 6. I get 12, just like that. And my b value is equal to negative 7. So far, so good. We need to find factors of 12 that add up to negative 7, right? Because it's a positive 12, my factors are either going to be both positive or both negative. And the only way to add factors to get a negative number is if they're both negative, right? So factors of 12 that add up to 7 are negative 3 and 4. Right there. Negative 3 and 4 add up to negative 7. Right? Negative 3 plus negative 4 is equal to negative 7, which is our b value. So now I can break down this polynomial like this. I get 2x squared minus 4x minus 3x, right? Plus 6. Cool, cool, cool. Now I can do x minus 1. And watch what I'm going to do. I'm actually going to group these. I'm going to group this and this. So here I am, I'll put it in brackets. And I'm going to group 2x squared minus 4x. Let me use purple so we can keep it consistent. Like that. And I'm subtracting these, the negative 3x plus 6 grouped. However, when I group them, I'm extracting a negative, which means this becomes 3x minus 6. You can redistribute the negative right here into both of them to get minus 3x plus 6. Remember, multiplying or dividing by a negative changes the symbol. So I have a minus the quantity 3x minus 6. And if I distribute the negative, I get that back. Let's keep going now. I have x minus 1, whatever this is, right? I know that 2x squared minus 4x, just by looking at it, it appears to me that they share a 2x, right? Here I have x, and here I have minus 4. You guys see that? If you distribute this back, you get back 2x squared minus 4. So far, so good. Minus, I can see that the 3x minus 6 share a 3. So I'm going to take out a 3. And then I get x. Oh, I'm sorry. There should be a 2 right here. My mistake. Right here. Because 2 times 2 is 4. Well, 2x times negative 2 is negative 4x. Apologies for that. I can continue now. So 3 times x is 3x. And in order to get a negative 6, I need a, this should be positive. I need a positive 2. Right? Let me check. Oh no, negative times negative is a positive. So this becomes a minus 2. Look at that. So minus 3 times x is Okay, quick, we're good. Yeah, we're good. 3 times x is 3x, and 3 times, yeah, we're good. So far, so good. All right, and this is in brackets, just like that. Making sure I did this correct. Just checking my math. Minus 2x, minus 2 times x is 2x squared. 2x times minus 2 is negative 4x. Yeah? Wait. I need a negative here because negative times negative is a positive. Yeah. My bad. I'm sorry about that, guys. Right, here's a negative. All right, now it makes sense. I was noticing something a little wrong. Apologies for that. If you caught it, good on you. Now let me check it. Negative 1 times 3x. Yeah, I can extract the 3. Yeah. All right, we're good. All right. Now, what I notice is that they share an x minus 2. You see that? This is factoring by grouping. So I'm going to take x minus 1 right here, my original one. And I notice that this whole polynomial inside the brackets, they share an x minus 2. Right? So I'm going to now take an x minus 2 and multiply it by whatever's remaining. Watch. 2x minus 3. Just like that. And from here, I can now find my remaining zeros. Right? Find all the zeros for the given polynomial function. All right, we have one from the factor theorem. This first one, right here. This was given to us, and we got to test it. So we're good on that. Now, let's find the rest. So our zeros. Right? We were given one, so there's a 0. X minus 1 is a 0. Right? And now to find the remaining zeros, I set these equal to 0. X minus 2 is equal to 0. X is equal to 2. So another 0 is x equal to 2. And then I set the last one I have to 0. Let's see what we get. 2x minus 3 is equal to 0. 2x equals 3. X equals 3 halves. And that's my last 0. X is equal to 3 halves, which is equal to 1.5. And those are my zeros. Let's graph this, right, to confirm my answer. And we're going to graph actually what we were originally started with, which was, oh Lord, look at all this work. This is what we started with right here, P of x. So I'm going to graph P of x and see if my zeros are correct. All right, let's graph it. So I have 2x cubed minus 9x squared plus 13x minus 6. All right, and from here I'm going to zoom in. Let's check my answer. Here are my zeros right here. There's one right there, x equals 1. Here's another one right there, x equals 1.5, the third one. They're not in order, but it doesn't matter. And let's check our last one. Whoop. Sorry guys, that's my Instagram. Feel free to follow. And here we have x equals 2. Voila. This is our first example. Just like that. All right. Don't worry if this is a little bit confusing. We're going to do more examples and hopefully it becomes more clear. Here I have number 2. And let's do it. I'm starting with P of x. Sometimes they're told f of x. It really doesn't matter if it's P of x or f of x. I just like saying P of x because it's a polynomial. So most of the time you're going to be given f of x because it's a function. So let's just start with f of x. So f of x equals 2x cubed plus x squared minus 5x plus 2. And they're asking me to use the given factor and the factor theorem to find all zeros for the given polynomial function. So f of x is given, and the factor they're giving me is x plus 2. All right, let's confirm if this is a factor, x plus 2. But this has to match the following format. It has to match this, x minus k. This does not match x minus k. So what we're going to do is we're going to rewrite it. X, right, minus, in order for it to be a positive 2, it has to be a minus 2, like that. So here we can clearly see that our k value is minus 2. Okay? So now I'm going to find f of negative 2, like that. Do not make the mistake of just plugging in whatever is along with the factor, okay? It has to match the format x minus k. Sometimes it's x minus a. I like saying k because a is a variable that's commonly used, and I don't like using variables that are used all the time because you might get confused on what they stand for. So I'm just using k. All right, let's find out if we get 0, because if we get 0, then x plus 2 is a factor. All right, so 2 times 2 cubed plus, negative 2 squared minus 5 times negative 2 plus 2. I know that negative 2 cubed is negative 8, so 2 times negative 8 is negative 16, plus negative 2 squared is 4, negative 5 times negative 2 is a positive 10, plus 2. This is negative 12 plus 10 plus 2. This is negative 2 plus 2 is equal to 0. All right. Therefore, by the factor theorem, we can confirm that x plus 2 is in fact a factor. So now let's use synthetic division to see what we have as our quadratic, because we're going to take this and divide it. Okay. So x plus 2 is a factor. So let's find out what you have to multiply by x plus 2 to get back our f of x function. Okay. So to do that, we're going to divide it, and we're going to divide using synthetic division. So minus 2, because that's what our root is, right? X equals 2 is our root. X equals negative 2, I'm sorry. And now let's grab our coefficients. First, let's check if we have to fill in anything. 3, 2, 1, 0. Nope, we have every degree. So we put our coefficients 2, 1, negative 5, and 2. All right. Let me zoom out a bit and let's synthetically divide. All right, here we go. Drop the 2. We get a 2 here. And we draw a line to keep ourselves organized. Negative 2 times 2 is negative 4. Atom, negative 3. Negative 2 times negative 3 is 6. Atom, you get 1. Negative 2 times 1 is negative 2. Atom, we get 0. And I'm going to put it off to the side here so we can see what we're doing. So now I have 2x squared minus 3x plus 1, which means that our function is now f of x is equal to the factor we were given, x plus 2, times whatever we found out through synthetic division. 2x squared minus 3x plus 1. All right, so this is my new one, right? I'm going to underline it with a highlight in blue. Is my new one, all right? Right there. So now I'm going to factor out the second degree polynomial. And to do that, I'm going to again use the ACB method. So A times C, right? I'm factoring this out. A times C is equal to 2. A is 2, C is 1. my b term equals -3. So I need two numbers that multiply to 2 that add up to -3. And I know that -2 times -1 equals 2. And I know that -2 plus -1 is equal to -3. So I'm going to use these two right here. All right. So my new f of x is now f of x is equal to x plus 2 and my 2x squared minus 3x plus 1 becomes 2x squared minus 2x minus x plus 1. So I'm going to focus on this right here. So let's zoom in on it. And now I'm focusing on this, all right? Right there. All right. So now I'm going to do the grouping method again. Let's do it. So I'm going to group these two, and I'm going to group this right there. Again, we have a negative. So when we extract it, the plus changes, right? Watch this. So x plus 2 equals, let's group these. I get 2x squared minus 2x minus, group these. I'm extracting a negative, which means this is now an x, and I'm extracting a negative from the plus 1, which means it becomes minus 1. Just like that. Cool. From the one in green, we can see that they share a 2x. 2x squared minus 2x, they share a 2x. So this becomes x plus 2. Okay. Two times x minus 2, x minus 1, I'm sorry. Yeah, just like that. X minus 1 minus, and it's just going to be x minus 1. And now we can see that we have x minus 1 and x minus 1. Look at that. Sorry, I forgot the bracket at the end. All right. So now let's keep going. I am now going to extract an x minus 1 from what we have in the brackets. So I still have that original x plus 2. And now I'm gonna extract the x minus 1. X minus 1, right? And whatever I have left over becomes my new binomial. It's a 2x. Oh, I don't see anything here. Wow, there's a hidden 1 in the front. Minus 1, just like that. Now we can find the remaining zeros, right? Let's find the remaining zeros. From here, to find the remaining zeros, we know this one are zeros. X equals minus 2. From here, just set it equal to 0. X equals 1. And from the last one, you get a half. Just like that. These are zeros. And you can plug this into the original f of x function, and you will, in fact, get 0. All right? This is going to be a factor. Cool, cool, cool. Awesome. Let's do another example. Get this back at 100. All right? And let me try organizing a little bit differently so we can clearly see what's going on. So this is going to be number 3 now. And I'm going to do the following. Oh, that one looks hard. like it. We have f of x is equal to 4x cubed minus 7x plus 3, and we're given the factor x equals 1. Cool. Let's check if this is a factor. All right. By the factor theorem, this is a factor if and only if f of k is equal to 0. In this case, k is equal to 1. So f of 1, if this is 0, then x minus 1 is a factor by the factor theorem. So 1 cubed minus 7 times 1 plus 3. 4 minus 7 plus 3, negative 3 plus 3, we get 0. So x minus 1 is in fact a factor. Okay? Let's find out what the remaining polynomial is, right? So f of x is equal to x minus 1 times the quotient polynomial. Q is a quotient. What I mean by quotient is if you divide this, right, the answer to the division problem is the quotient. So I'm going to synthetically divide. My coefficients are 4. We're missing an x squared term, 0. We have a x term, right, which is negative 7, and then we have a constant term, which is 3. Whatever my answer is down here, that's going to be my q of x. That's my quotient. Okay? The remainder is going to be 0 because f of 1 is 0. So we don't even need to put plus r of x, which is the remainder. We don't need that because it's just 0. Okay? So let's find what q of x is. Drop the 4. 1 times 4 is 4. Add it. 4. 1 times 4 is 4 again. Add it. Negative 3. 1 times negative 3 is negative 3. Add it. 0. So my q of x is 4x squared plus 4x minus 3. Cool. So f of x is equal to x minus 1 times 4x squared plus 4x minus 3. Just like that. Cool. Let me move it down now. And here we go. Remember, this is our quotient, okay? This is q of x because it's the answer to our division problem. That means it's a quotient. Little terminology for us. All right. Now we need to find numbers, right? We need to find the remaining factors of 4x squared. So I'm going to take 4x squared and I'm going to do it off to the side over here. All right. So let's just split this up. Just so we can split it up, okay? Oh, Lord. This is off to the side, okay? This in the red, right over here, is just my synthetic division to find what q of x is. All right. Let's take q of x, 4x squared plus 4x minus 3. And I'm going to factor it using the ACB method. A is equal to 4 and C is equal to negative 3. So 4 times negative 3, A times C. Let me do it clearly. A is equal to 4. C is equal to negative 3, which means that A times C is equal to negative 12. Just like that. And my B value is equal to 4. It's a positive 4. And the only way to get negative 12 is if one is positive and one is negative. But because they have to add up to 4, that means that I have 6 times negative 2. Add those up, you get 4. Okay? It just becomes easier as you do this type of problem. you should be able to spot what the factors add up to. All right, here we go. I'm gonna split up 4x squared now. So 4x squared plus 6x minus 2x minus 3. I always like putting the bigger one out in front, but the order doesn't really matter as long as you do it correctly. So I'm gonna group these, right? Do it in green. I'm grouping these right there. And then I'm gonna group this right here. All right, let's keep going. I'm gonna move it down. I'm working this right now, okay? All right. Four x squared plus 6x minus, right? Well, I extracted a negative, which means that the inside is actually 2x plus 3. If you distribute the negative back, you get minus 2x minus 3. Be very careful when you have a minus in the middle. The positive won't change anything, but the minuses do. All right, looking at the terms I have inside the green, I can see that they share a 2x. Just like that. And on the inside, I get 2x plus 3 minus, hey, look at that, 2x plus 3. Cool. Now, I can write it like this. 2x plus 3, because that's what they share. And I'm multiplying it to 2x minus 1. Just like that. So this is q of x, remember? It was just factored out. I factored out q of x out. So now I can go back here and rewrite it. So f of x is equal to the original factor they gave us. And then there are other factors we have. We're going to have 3 factors because we started with a cubic polynomial. And it's going to be 2x plus 3 and 2x minus 1. Let's see if this is in fact a factor. Okay? Let's check them. So I'm going to set them equal to 0. 2x plus 3 is equal to 0. From here, I recognize that it's going to be x equals negative 3 halves. Right? This is how you check if it's a factor. And let's check if this is a factor. 0. From here, I recognize that x equals positive 1 half. Let's plug this into f of x to see if we do in fact get 0. Because if 3 halves gives us, if f of 3 halves, negative 3 halves gives us 0, then this is a factor. Okay? Let's just test it one time, and you guys can test the other one if you want. So I'm going to test f of negative 3 halves. So this becomes negative 3 halves minus 1 times 2 times negative 3 halves plus 3. Right? I'm just plugging in where x would normally be. Times 2 times negative 3 halves minus 1. Like that. Okay? Let me... 3 halves. Oh, that didn't work. 3 halves is right here. Look at that. That one. So here's the first one, x minus 1. Here's the next one, 2x plus 3. And here's the last one, 2x minus 1. Cool, cool, cool. Watch this. This is equal to negative 3 halves minus 1 gives us actually negative 5/2. And the next one is 2 times negative 3/2 is actually equal to -3 plus 3. Hey, look at that. This one is 0 right there, which means we really don't care what this next one is. If you want, I'll do the math anyway. 2 times -3/2 gives us -3 minus 1. So that's going to be -4. So minus 5/2 times 0 times -4 is equal to 0. Therefore, negative 2/3 is a root, which means that our original one right here is in fact a factor. This right there is a factor. Cool, cool, cool. You guys can test the 2x minus 1 and you will in fact get 0. Okay, so I'm gonna erase all of this now. Go ahead and test it. Little exercise for y'all. I challenge you to do it. Cool, cool, cool. Let's keep going, erasing slowly. So these are my zeros. Negative 3/2, 1/2, and the one we started with, which is x is equal to 1. So these three right here are the zeros of my first polynomial. Why isn't it making it a nice? No. Oh, there it is. All right. Let's graph the polynomial we started with to see if we in fact get these zeros. So negative 1.5, 1, and 0.5. Let's graph them right here. I don't need to get rid of that. I just change this into a 4. And then we have minus 7x plus 3. There they are. Negative 1.5, good. 0.5, good. And 1, good. We did it. Good work, guys. So I hope this teaches you a little bit of how to apply the factor theorem. Remember, it's only a factor if f of k is equal to 0. I tested it in this last example, negative 3/2, and you do get 0, which means that our original is a factor. All right. You could rewrite it like this. You might be tempted to say, well, it's x minus k, so why didn't you write it as x plus 3/2? You can. This is totally acceptable. But the problem is that it's ugly. We have a fraction, right? So if I multiply it by 2, you get 2x plus 3, right? Which is what our original was, right there. But let's keep it pretty, right? We factored it like that, so that's what we're going to use. In order to find what that 0 is, just set it equal to 0, and you'll see that it matches. Cool, cool, cool. All right, everybody. That's it for the factor theorem. I hope this clears up a bit on how to do it. It's a lot of work, but at the end of it, you know, it can be done. So I hope this helps. Please leave a comment, like, and subscribe. If you need more clarity on more examples, I'll be happy to do that. But if not, just let me know. And I'm also testing on this new mic. Let me know how it sounds. Take it easy, guys.